Okay, so we're going to get into some, we're going to work backwards today, and we're going to get into some applications, okay? Actually, today, some of you might see some overlap from what you've done in physics, if you are in physics, okay? So let's think about our vector, okay? Here's our vector v. Let's say that you know the direction angle and you know the magnitude. If our vector is the vector a comma b, that means the horizontal component is a and the vertical component is b. What if I asked you, what is the horizontal component? What is the vertical component? Take a moment at your pause to talk about how might we be able to figure out horizontal and vertical component if we know the magnitude and direction. Take a moment to talk about it. How do we find the blue if we know the black? 1, 2, 3, go. All right, Madeline, if I wanted the horizontal component, aka A, how might we find that? If we know magnitude,
Cosine.
okay, that made it look really bad. Okay, we know that the cosine of theta is adjacent over hypotenuse, right? So we could say that our horizontal component is the magnitude times the cosine of theta, right? If we just multiply that over. Okay. Mia, what about our vertical component, b? How might we figure that out? Okay, we know that the sine of theta is opposite over hypotenuse. So we could rewrite this to where b, or our vertical component, is the magnitude times the sine of the angle. I really love how the horizontal component involves cosine and the vertical component involves sine. Right? That seems a little bit familiar. Okay. So what we're going to do, we'll make it official here. Okay. If we want a vector and we know our magnitude and direction, then this is what it's going to look like. In component form, we would do magnitude cosine of theta, magnitude sine theta for each of the two components. And then linear combination form, that's what we would put in front of the I and the J. Okay, so we're going to do an example, if you're ready. I see some pencils still moving, so I'll take them over here. Actually, I have two different types of examples that you're going to see. The first one we're going to do very straightforward. The second one we're going to do, we need to take a couple turns before we get there. So here's our first example. I want the component form of V if we know that the magnitude of V is 2 and the angle is 45 degrees. Well, we know that for our horizontal component, all we need to do is take the magnitude times the cosine of our angle. And for our vertical component, we know we need to take the magnitude times the sine of our angle. Okay. I don't know if I said this on Friday, but if you have an angle that is a unit circle angle, I would like the exact value. I don't want you to type this into your calculator. If you have a unit circle value, I want you to give it to me exact. So what is the cosine of 45 degrees? We know that that's radical 2 over 2. And if we take radical 2 over 2 times 2, we get radical 2. Same thing here. The sine of 45 degrees is radical 2 over 2. So when we multiply it by this 2, we're left with radical 2. So here is the component form for our vector V. Here's example number 2. Here I'm giving you that the vector has a magnitude of 3, but then V is in the direction of negative 3i plus 4j. All right, so if we are going to set up our vector, magnitude cosine theta, magnitude sine theta, what are we going to need to find first? We need to know the direction, theta. Okay. Now it says V is in the direction of this. Okay, I don't care about this vector's magnitude. I care about its direction. They're in the same direction. So we need to find the direction angle for negative 3i plus 4j. Okay, I'm going to give you 60 seconds to work together in your pod to come up with what the direction angle is for negative 3i plus 4j. Okay? The direction angle was a part of our warm-up problem. We'll go over it, but work together first. Veronica, what did pod 4 come up with for a direction angle? 126.87. Wait, what?
87.
Okay, and what did you do to get there?
I did the inverse tangent of 4 over -3, and then subtracted that number from underneath.
Because it gave you like 53.13.
Yeah.
Okay. So we have the inverse tangent of y over x. Okay. That's going to give you an acute angle. But Veronica and pod 4 knew that this -3i plus 4j was in the second quadrant. So our angle needs to be in the second quadrant. So you get an acute angle with the inverse tangent. Now place that reference angle in the second quadrant. So 180 minus 53.13 is going to give you that angle in the second quadrant. Okay. Questions before we keep going? Okay, let's say that we had a third quadrant angle. Then we need to take 180 plus the reference angle. All right? If we're in the fourth quadrant, we take 360 minus our reference angle to get there. Okay? I'm going to encourage you to really ignore the negative of your reference angle. Reference angles are always positive. So if your reference angle is negative, just ignore it for when you do your calculations. Okay? All right. So now that we have our direction angle, we can say that vector v is the magnitude 3 times the cosine of our direction, and the vertical component would be 3 times the sine of that angle. Okay. So in your calculator now you have two calculations. You have 3 times the cosine of 126.87, figure out what that is, and then you have 3 times the sine of 126.87. Okay.
Negative 1.80i plus 2.399.
2.399, so 2.4. Okay. Okay. Questions?
Since we got that the v is in the direction of -3i plus 4j, should we keep it in the linear combination form, or should we put it back in?
Oh, in form? So, my directions up at the top, which I don't know if I even pointed out, it says find the component form of v. So in this case, I know that I gave you linear combination form, but it's specifically asked for component form. Okay, that's a good question. Okay, unless I say specifically give it to me in this form, then keep it in the form of. So you just heard me. All right, another type of question. Here I have the magnitude of indirection of two vectors, and I want the sum of u and v. So I'll give you a moment to write down what you need to. And then we'll work together on getting to the answer. Okay, when we added vectors Friday, what form were they in when you added them? They were in component form, right? Or linear combination form. But we had to have the components to add together. Horizontal components added together, vertical components added together. Do we have vertical and horizontal components right now? No, which means we cannot add these together until we have those components broken apart. All right? So what we're going to need to do for each of these is write them in component form, and then we can add them together. All right? So for vector U, our magnitude is 4, and our angle is 60. Kaden, what's the cosine of 60? Is he even sure?
I was mixing up 60. Oh, I'm mixing it up with 30 degrees. It's 1/2.
Okay, you feel better about that one? Okay. 4 times 1/2 would then be 2. And if the cosine of 60 is 1/2, then the sine of 60 is radical 3 over 2. Times 4 is our 2 radical 3. Okay. Since we have a unit circle angle, I want you to keep them exact. Vector V has a magnitude of 5 and an angle of 90. So if we break that apart to horizontal and vertical, what's our horizontal component going to be? Vertical? 5. Okay. Now that we have the component forms, we can find the sum. So our sum, U plus V, is going to be 0 plus 2 and 5 plus 2 radical 3. But 5 plus 2 radical 3 can't actually be added together, so we're going to have to just leave it written as 5 plus 2 radical 3. And that's what I would expect. Okay? Since we can give it exact, I'd like us to go ahead and do that. Why would we want to be able to add vectors together? Okay, my physics people, typically you use vectors to represent what? Okay, so what if two forces are acting together on one particular item? Okay, we would need to add those forces together to know what's actually happening to that item. Okay, and that's the example that we're going to do next. So we have forces with magnet, and I'm just going to read this first, and then I want you to decide kind of how you want to write this down. I don't think you should write every word, all right? But let me read it, and then you decide what things you want to write down. So we have forces with magnitude 2,000 newtons and 900 newtons that are acting on a machine part at angles of 30 and negative 45 respectively. So that means the force with 2,000 newtons has an angle of 30, and the force of 900 newtons has an angle of negative 45. Okay? Find the direction and magnitude of the resultant of these forces. So when these two forces are acting together, when we combine them, what's really happening? All right? Go ahead and write down what you think you need to. I'll give you a minute or so to write down information, and then we'll work together to figure this out. So I want to know the magnitude and direction of the resultant. Okay, we've seen that word. Resultant has been referring to what about two vectors? What do we need to do with the two vectors? We need to add them together. All right? And we just, in the previous example, looked at if we have two separate vectors that we need to add together, we need them to be in their component forms first. Okay? So let's start with our green vector. Our green vector has a force of 2,000 newtons and an angle of 30 degrees. Hayden, what is the cosine of 30 degrees? Yes. So if the cosine of 30 is radical 3 over 2 times 2,000, we're looking at 1,000 radical 3. And 2,000 times the sine of 30 is just going to be 1,000. Now let's look at our blue vector. I'm just going to call it vector V. Vector V has a magnitude of 900 with an angle of negative 45. Okay, so vector V, we know that cosine and sine at 45-degree angles are radical 2 over 2. But since we're talking about negative 45, the cosine is going to be negative radical 2 over 2. So we're talking about negative 450 radical 2. And then here, this is going to be a positive 450 radical 2.
Would it be the opposite of 15?
Oh, I totally put the negatives on the wrong ones, didn't I? This is a positive and this is a negative. Thank you. Cosine is positive. Sine is negative. All right. So now we want the resultant of these two forces. So now we need to add them together. All right, so U plus V is going to be, yikes. We have 1,000 radical 3 plus 450 radical 2. That's our horizontal component. Not pretty, but that's what it is. And then we have 1,000 plus negative 450 radical 2 for our vertical component. So I'm going to call these A and B. All right? And this is what I'm going to do in my calculator so that I don't have to worry about order of operations or messing up with the parentheses or what have you. I'm going to go ahead and in my calculator, what was A? It was 1,000 radical 3. And then plus 450 radical 2, right? Okay, I'm going to actually figure out what that is, and I'm going to store it in alpha A. Store alpha A. That way I can just come back to it later. Okay. And I'm going to do the same thing with our vertical component. Our vertical component was 1,000 minus 450 radical 2. And I'm going to store, remember this is my store button, that value in B so I can come back to it. Now, if you want to just arrow up and select them, that's fine too. I'm just trying to make it easier for the number of buttons that I have to push. So, if I want the magnitude and direction, I know that the magnitude is just going to be the square root of a squared plus b squared. Right? So in my calculator, all I would have to do is say the square root of a squared plus b squared, and then I don't have to type those numbers in and be worried about me missing a parentheses, missing a sign, something kind of crazy like that. And I also don't have to worry about rounding errors. Okay, so our magnitude is 2,396.19. Oh, that's not.
How did you store the values?
So once I got the answer, I hit this button right here, store, and then alpha A or alpha B. So 2,396. What was my decimal point? What? 19. And that would be newtons, because that's what we were talking about. That was the label for our magnitudes to begin with. Okay. I also wanted the direction angle. Okay. Well, we know that the tangent of theta is b over a, vertical over horizontal. Okay. Both a and b were positive numbers, weren't they, when we calculated those? So we should have a first quadrant angle. That's going to be fine. So in our calculator, we can take the inverse tangent of b over a, and that actually is the angle that we want, 8.73 degrees.
Wait, why is that?
Why does what work?
Like, why can you do it like that?
This is how we've been doing it. We've been taking the inverse tangent of vertical over horizontal. I'm just not actually like writing out the big ugly number. Does that make sense?
Yeah, I missed
That's okay. All right, so what this machine part is actually feeling is 2,396 newtons at an 8-degree angle. The two forces are creating this one force, and that's what it's feeling. I have one more thing I want to talk about, and then we'll be done. If I give you some sort of scenario, a slingshot is fired at a velocity of 30 feet per second at a 20-degree angle. Anybody used to or still have a slingshot? Okay. If I ask you for the vertical and horizontal components of velocity, I'm really just asking you for the two separate forms. Just throw a label on it. 30 feet per second, the velocity, what is that describing about our vector? What? True. But if we were to like label something on a vector, okay, aka its magnitude. So 30 times the cosine of 20 degrees would be our horizontal component. 30 times the sine of 20 degrees would be our vertical component. Help me out. What is 30 times cosine of 20? 28.19. And we would label in feet per second, since that's what the magnitude was labeled in. And then 30 times the sine of 20. 10.22. And we will label that in feet per second. Okay? So what's happening Like if I were to be like dead on with whoever is shooting the slingshot, okay, I would really only be able to see that rock move up. Like I wouldn't be able to see the horizontal change. So I would see it moving up at 10 feet per second. But if I were to be standing here and they were shooting it this way, I would see that rock fly horizontally, and horizontally I could see that velocity be 28 feet per second. Now the rock is traveling 30 feet per second, but if you look at the different perspectives, you're only seeing that particular movement. All right, so really, in your homework, you need to be able to take angle of direction and magnitude and write the two different components. Sometimes add them together, sometimes just stop there. That's really the basis of everything that we did. Okay? All right, make sure your quiz is in the basket, and I will see you tomorrow. Have a wonderful Monday.